AFCI circuit breakers can sometimes generate more heat than standard breakers, and this has been observed in areas beyond just Vermont. Several factors can contribute to this issue. Firstly, AFCI breakers constantly monitor the electrical current in the circuit they protect, specifically looking for arc faults. This monitoring process, while essential for safety, draws a small amount of current continuously. This small but continuous current draw contributes to the overall heat generation within the breaker. Secondly, manufacturing defects or design flaws in the AFCI breakers themselves can sometimes lead to excessive heat buildup. This is not necessarily a widespread problem, but it can occur in individual units. Thirdly, even though AFCI breakers are designed to protect against overloads, they can still generate heat if they are subjected to prolonged overloading. Even if the overload isn't severe enough to trip the breaker immediately, the sustained higher than normal current flow can cause the breaker to heat up over time. Several mitigation strategies can be employed to address the heat generation issue with AFCI breakers. One strategy is spacing AFCI breakers. This involves separating AFCI breakers from each other with standard circuit breakers in the panel. The standard breakers act as spacers, allowing for better air circulation and heat dissipation around the AFCI breakers. This practice is already in use in Vermont. Another strategy involves using heat-resistant breakers. Some manufacturers offer AFCI breakers that are specifically designed to dissipate heat more effectively. These breakers may incorporate design features such as larger heat sinks or improved ventilation to help manage the heat generated during operation. Another tactic is ensuring circuit balance. Distributing electrical loads evenly across multiple circuits and panels helps to reduce the thermal burden on individual AFCI breakers. This prevents any one breaker from carrying an excessive amount of current, minimizing heat generation. Regularly monitoring circuit loads and avoiding overloading AFCI breakers is another way to prevent excessive heat generation. Ensuring that circuits are not consistently operating near their maximum capacity can help to reduce the overall heat load in the breakers. To further elaborate on the heat generation due to current monitoring, it's important to understand how AFCI breakers function. They use sophisticated electronics to detect the unique characteristics of arc faults, which are dangerous electrical discharges that can cause fires. This detection process involves constantly sampling and analyzing the current waveform in the circuit. The electronic components used in this monitoring process consume a small amount of power, and this power consumption is dissipated as heat. While the amount of heat generated by a single AFCI breaker may be relatively small, the cumulative effect of multiple AFCI breakers in a panel can be significant, especially in densely packed panels. Component defects can also contribute to heat generation. For example, a faulty capacitor or resistor in the AFCI breaker's electronic circuitry could draw excessive current, leading to increased heat buildup. Similarly, a loose connection or corroded contact point within the breaker could create resistance, which generates heat as current flows through it. Overloading, even if not severe enough to trip the breaker, can still cause significant heat generation. When a circuit is overloaded, the current flowing through the breaker exceeds its rated capacity. This increased current flow causes the internal components of the breaker to heat up. If the overload is sustained for an extended period, the heat buildup can become excessive, potentially damaging the breaker and increasing the risk of a fire. Spacing of AFCI breakers is a simple and effective way to improve heat dissipation. By inserting standard breakers between AFCI breakers, you create air gaps that allow for better ventilation. This helps to remove heat from the AFCI breakers, preventing them from overheating. The effectiveness of this strategy depends on the layout of the panel and the amount of space available. Using heat-resistant breakers is another proactive approach to managing heat generation. These breakers are designed with features that enhance their ability to dissipate heat. For example, they may have larger heat sinks, which are metal components that absorb and dissipate heat. They may also have improved ventilation with openings that allow for better airflow around the breaker. These design features help to keep the breaker cooler, reducing the risk of overheating. Ensuring circuit balance is also crucial for preventing heat generation. When loads are unevenly distributed across circuits, some circuits may be heavily loaded while others are lightly loaded. The heavily loaded circuits will draw more current, causing the breakers to heat up more than the lightly loaded circuits. By balancing the loads, you can distribute the current more evenly, reducing the thermal stress on individual breakers. Regularly monitoring circuit loads is essential for identifying and correcting potential overloads. This can be done using a clamp meter, which measures the current flowing through a conductor without having to disconnect it. By measuring the current on each circuit, you can identify any circuits that are consistently operating near their maximum capacity. If you find any overloaded circuits, you should take steps to reduce the load, such as moving some of the appliances or equipment to a different circuit. In addition to these mitigation strategies, it's also important to ensure that the electrical panel is properly installed and maintained. The panel should be located in a well-ventilated area, away from sources of heat or moisture. The breaker should be securely mounted and properly connected to the bus bars. The panel should also be inspected regularly for signs of damage or corrosion. The National Electrical Code, or NEC, provides guidelines for the installation and maintenance of electrical panels and circuit breakers. Adhering to these guidelines can help to ensure the safe and reliable operation of the electrical system. Specifically, Article 408 of the NEC covers switchboards, switchgear, and panel boards. This article provides requirements for the location, installation, and wiring of these components. Article 240 of the NEC covers overcurrent protection, including circuit breakers and fuses. This article provides requirements for the selection, installation, and protection of overcurrent devices. These articles provide detailed information on the proper installation and maintenance of electrical panels and circuit breakers. Consulting these articles can help electrical professionals to ensure that their installations comply with the NEC requirements. In addition to the NEC requirements, some local jurisdictions may have additional requirements for electrical installations. It's important to check with the local authorities to determine if there are any specific requirements that apply in your area. It's also important to note that AFCI breakers are not a substitute for proper wiring practices. AFCI breakers are designed to protect against arc faults, but they cannot prevent all electrical fires. Proper wiring practices such as using the correct wire size, making secure connections, and protecting wires from damage are essential for ensuring the safety of the electrical system. In conclusion, the heat generation issue with AFCI circuit breakers is a real concern that needs to be addressed. By understanding the causes of heat generation and implementing appropriate mitigation strategies, electrical professionals can ensure the safe and reliable operation of AFCI protection. The strategies are spacing AFCI breakers, selecting heat-resistant breakers, ensuring circuit balance, avoiding overloading, and adhering to the NEC requirements. By taking these steps, you can minimize the risk of overheating and ensure the long-term performance of your electrical system. Furthermore, consider that the internal resistance of wiring and connections can play a significant role in heat generation. Higher resistance leads to increased heat production, according to Joule's law, which states that the heat generated is proportional to the square of the current multiplied by the resistance. Therefore, ensure all connections are tight and free of corrosion, and that wiring is appropriately sized for the load to minimize resistance and heat. Using thermal imaging cameras can also be helpful in identifying hotspots within electrical panels, allowing for proactive maintenance and prevention of potential issues. Thermal imaging allows electricians to see the temperature distribution of components, quickly identifying areas of excessive heat that may indicate loose connections, overloaded circuits, or failing components. Regular thermal inspections can help prevent costly downtime and improve overall electrical safety. Another aspect to consider is the ambient temperature of the environment where the electrical panel is located. If the panel is in a hot or poorly ventilated area, the breakers will naturally operate at a higher temperature. Improving ventilation or reducing the ambient temperature can help to mitigate heat generation. For example, installing a fan to circulate air within the panel or relocating the panel to a cooler location can help to reduce the operating temperature of the breakers. Also, be aware of the duty cycle of the circuits protected by AFCI breakers. Circuits that are used continuously or for long periods of time will generate more heat than circuits that are used intermittently. For example, a circuit powering a server or a refrigerator will generate more heat than a circuit powering a light fixture that is only used occasionally. Therefore, consider the duty cycle when designing and balancing circuits to minimize heat generation. In addition to using heat-resistant AFCI breakers, consider the overall quality and design of the breakers. Some breakers are designed with more efficient cooling mechanisms and higher quality components, which can help to reduce heat generation. Researching and selecting high-quality AFCI breakers from reputable manufacturers can help to improve the reliability and longevity of the electrical system. Also, remember that AFCI breakers are designed to trip under specific conditions, such as when an arc fault is detected. Frequent tripping of AFCI breakers can indicate a problem with the wiring or appliances on the circuit. Addressing the underlying cause of the tripping can help to prevent unnecessary heat generation and improve the overall performance of the circuit. Consider the impact of harmonics on AFCI breaker performance. Harmonics are distortions of the electrical waveform that can be caused by nonlinear loads such as electronic devices and LED lighting. Harmonics can increase the current flowing through the circuit, leading to increased heat generation in the AFCI breaker. Using harmonic filters or mitigating the sources of harmonics can help to reduce the impact of harmonics on AFCI breaker performance. Finally, ensure that all electrical work is performed by qualified and licensed electricians. Improper wiring or installation can create hazards that can lead to heat generation and other electrical problems. Hiring a qualified electrician can help to ensure that the electrical system is installed and maintained safely and correctly. Proper torque on breaker connections is critical. Under-torqued or over-torqued connections create increased resistance, and increased resistance creates heat. Using a calibrated torque wrench and following manufacturer specifications for torque values ensures a solid and reliable connection, minimizing heat generation at the breaker connection points. Periodically inspect the electrical panel for any signs of water intrusion. Water can cause corrosion and increase resistance in connections, leading to heat generation. Addressing any water leaks promptly and ensuring the panel is properly sealed can help prevent corrosion and maintain safe operating temperatures. Consider the use of solid-state AFCI breakers, which use electronic components instead of mechanical contacts to interrupt the circuit. Solid-state breakers can offer faster tripping times and longer lifespans compared to traditional mechanical breakers. While they may be more expensive, they can offer improved performance and reliability in critical applications. Also, consider the use of smart breakers, which can provide real-time monitoring of current, voltage, and temperature. Smart breakers can alert you to potential problems, such as overloads or excessive heat generation, allowing you to take corrective action before a serious problem occurs. Smart breakers can also be integrated with building automation systems to provide remote monitoring and control of electrical circuits. When replacing AFCI breakers, always use breakers that are specifically designed for the application. Using the wrong type of breaker can compromise safety and performance. Consult the manufacturer's specifications and the NEC guidelines to ensure that you are using the correct breaker for the circuit. Remember that AFCI breakers are designed to protect against specific types of electrical faults. They are not a substitute for other safety devices, such as ground fault circuit interrupters or surge protectors. Using a combination of safety devices can provide comprehensive protection against electrical hazards. Also, be aware of the limitations of AFCI breakers. They may not be able to detect all types of arc faults, particularly low-level arc faults that occur in older wiring. Regular inspections of the electrical system can help to identify potential problems before they lead to more serious hazards. It's also crucial to educate homeowners and building occupants about the purpose and function of AFCI breakers. Informing them about the importance of not overloading circuits and reporting any electrical problems promptly can help to prevent electrical fires. Consider implementing a preventative maintenance program for the electrical system. This program should include regular inspections, testing, and cleaning of electrical panels, wiring, and devices. Preventative maintenance can help to identify and correct potential problems before they lead to equipment failure or safety hazards. Proper labeling of circuits in the electrical panel is essential for safety and convenience. Clearly labeling each circuit with its corresponding load can help to prevent accidental overloads and make it easier to troubleshoot electrical problems. When working on electrical systems, always use appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. Following safety precautions can help to prevent electrical shocks and other injuries. Consider the use of power quality monitoring equipment to analyze the electrical waveform and identify any distortions or anomalies. Power quality monitoring can help to detect problems such as harmonics, voltage sags, and transients, which can impact the performance and lifespan of electrical equipment. Regularly review and update the electrical system documentation, including panel schedules, wiring diagrams, and equipment specifications. Accurate documentation is essential for troubleshooting and maintaining the electrical system. Consider the use of energy-efficient lighting and appliances to reduce the overall electrical load and minimize heat generation. Energy-efficient devices consume less power and generate less heat, which can help to improve the performance and reliability of the electrical system. Finally, stay up to date on the latest electrical codes, standards, and technologies. The electrical industry is constantly evolving, and it's important to stay informed about the latest advancements in safety and performance. Continuous learning and professional development can help to ensure that you are providing the best possible electrical services. By considering these additional factors and implementing appropriate measures, you can further mitigate the heat generation issue with AFCI circuit breakers and ensure the safe and reliable operation of the electrical system.